part, I would need a moment about a specified axis. Well, we know, we've already discussed this, it's the scalar triple product. Unit vector of OB dotted with R cross F to get the moment about OB. I'm projecting that moment onto line OB. Agreed? So, unit vector, remember, go back to the dot product. What was one of the uses? Second use was projection of a vector onto a line. How do I do it? Unit vector of the line dotted with the vector. Well, in this case, the vector happens to be the moment. How do I calculate moment? R cross F. And then I dot that with the unit vector of the line. So you can see, I'm showing it to you. Unit vector of the line dotted with R cross F, this is the moment. You with me? Now, very important. If you're sleeping, wake up for a second, then go back to sleep. I don't know how you can sleep with me being so loud. I just don't. But some people can. What is the R? Notice the definition of the R. Position vector directed from any point on the axis, OB in our case, to any point on the line of action of the force. So you're going from the axis to the force. Everybody heard that? From the axis that you're trying to project onto, which in our problem here is going to be OB, to the line of action of the force. And we've already stated that this triple product you can set up as determined where the first row is the unit vector in terms of its components. The second row is the R that goes from the line to the force in terms of its components. And of course I need the force in terms of its components. Then you do that triple product and you got it. Yes? Okay. So, first and foremost, X, Y, Z. Not Hitler's, but it's definitely a right-handed coordinate system. Yes? Now it says this force here is 100 pounds. And I want to know the moment about O, about the x-axis, and then about the diagonal OB. So I check the coordinate system next. There is no alpha, beta, gamma. There is no double projection, but there is a bunch of distances. So I got to go through the 5-step process to get the force in I, J, K. Any 3D problem has to be put in I, J, K format. So let's do it. Coordinates of C, 3, 3, 0. Coordinates of A, 0, 3, 3. Therefore, our CA vector is XA minus XCI plus YA minus YCJ plus ZA minus ZCK. Who's not with me? Speak or forever hold your peace. All right. RCA vector is 0 minus 3, that's a minus 3i. 3 minus 3, that's a plus 0j. 3 minus 0, that's a plus 3k. Please notice, I'm putting a 0 there. I don't have to, but I do it for placement. Magnitude of RCA I need, which in this case is 4.242. Therefore, FCA vector is 100 times the unit vector of CA. That's going to be 100 times minus 3i plus 0j plus 3k. Divide this by 4.242. Boom. FCA vector is minus 70.721i plus 0j plus 70.721k. Bingo. Chapter 2 complete. I have my course in terms of IJK. I need a moment. How do I get a moment? R cross this stupid F that I just got in IJK. Well, what the hell R do I use? I need an R that goes from the moment center, which in this case is O, to any point on the line of action of the force. Please note, I can use ROA. I can use ROC. Yes? Any of those are legit. I could use anything in between. So these are the obvious ones, but I can use any of these. Any R will work. Any of those red arrows will work for the R. Obviously, the easiest ones are either OA or OC. That's it. Because I know coordinates. So I'm going to come in and I'm going to say moment about O is equal to ROA crossed with FCA. Well, that's going to be IJK of ROA. That's going to be 0 minus 0, that's 0I. 3 minus 0, that's going to be 3J. 3 minus 0, that's going to be 3K. The force is the force. It's minus 70.721, 0, and 70.721. Do the math. Moment about O is equal to 212.163 pi minus 212.163J plus a 212.163K. This is your MX, this is your MY, and this is your MZ. Yeah. Now, I didn't do the actual cross product. Hopefully you know how to do that by now. That's why we stopped and we did the vector algebra review. So everybody should know how to do that. If you don't, then you better find a calculator that can do cross products and set it up. And then just tell me, by my TI 85 or 84 or whatever the hell you have, I get this values for moment. So part A and part B are already answered. Part B said, what's the moment about the X? Well, there it is. 212.163. Now it says, hey, I want you to find me the moment about the diagonal OB. Project this onto line OB. Well, instantly my mind says, hey, moment OB is equal to unit vector OB dotted with R cross F. Check, I have F. Already have F. Already done it. Wow.
Can we just use the vector projection formula?
See, there he goes. What is the vector projection formula? Huh? What the hell are you talking about? I don't know what you're saying. There's this formula. Okay, what is the formula?
I'll write it down for you.
Write it down and then tell me what it is, so I can write it down so everybody can see your magical formula. I need an R and I need the unit vector OB, which means I need to stop and say ROB vector is XB minus XOI plus YB minus YOJ plus ZB minus ZOK. That's really equal to, here's B. What are the coordinates of B, damn it? Coordinates of B are what? Yeah, 3, 3, 3. What are the coordinates of O? 0, 0, 0. So what would ROB be? 3I plus 3J plus 3K. What the hell is the magnitude of this guy? That's going to be 5.196. So what's the unit vector of OB? It's 3I plus 3J plus 3K. And I'm going to divide this by 5.196. Unit vector OB, therefore, is equal to 0.577I plus 0.577J plus 0.577K. Got OB. Perfect. I'm missing one thing, and I need the R. Remember, this R in the triple product is a vector that goes from the line, which is OB, to any point on the line of action of the force. Yes? What are those possibilities? Here are the possibilities. Here's the line, going from the line to the force. Well, the possibilities are ROA, ROC, RBA, RBC. Those are all the possible ways I can get to R. Remember, R goes from OB, the line, to any point on the line of action of force. So O to A, that's on the line of action of the force. O to C, that's on the line of action of the force. B to A, that's on the line of action of the force. And B to C. So any of these will frickin' work. So moment OB is equal to 0.577, 0.577, 0.577. I could use 330. This would be OC. That would be minus 70.721, 70.721. I can do that. That'll do it. If I do this, MLB will come out to be a value 122.418. Dang. Nice. I could also use RBA. Well, what is BA? 3 minus 0, which is 3. I'm sorry, 0 minus 3, which is minus 3. 3 minus 3 is 0. 3 minus 3 is 0. That's even better. I like that better because now if I use RBA, I'm going to say 0.577, 0.577, 0.577, and this here will be RBA. And we said it's 0 minus 3 minus 3i. Then I'm going to say 3 minus 3, that's 0. And then 3 minus 3, that's 0. Oh, I like that even better. You know why I like that even better? Because the more zeros you have in the determinant, the easier it is to calculate the determinant. Did you ever hear that? Pick an R that has a ton of frickin' zeros. Why? Because it's very easy to calculate the determinant with a ton of zeros. So this would be more of a good way to calculate than that is. Could I use this? Yes, I just did. And then this would be minus 70.721, 0, and 70.721. Perfect. I love it. Now what I want you to do is redo the problem and try it with a different R. Go with RBC. Go with ROC. No, I already used those. OA. See if you don't get 122. Now, what's another way I could have done this? Easily. Here's the other way I could have done this. I didn't have to do all this. I have R cross F. It's that. Correct? That's the moment. Because that's what this is, moment. So I could have done this. Moment OB is unit vector OB dotted with MO. This would have been 0.577I plus 0.577J plus 0.577K. And I'm going to dot that with 212.163I minus 212.163J plus the 212.163K. If I do that, I'll get the same damn answer. Isn't that wonderful? So there's more than one way to beat this problem. Questions, thoughts, comments, ideas, anything bother anybody? Questions? Yeah.
How would you want to write our final
Right there.
Even if it has one that's like, what's the moment about O and moment about the x-axis?
You're going to tell me moment about O, that's part A. Moment about B, that's this. Or moment about the x-axis, that's part B, that's part A, that's part C. That's all I need. Yeah.
Can you just speak on the whole usage of RDA again, by the way?
What's that?
Can you just speak on the whole usage of RDA at the end there? Where you had -300?
What about it?
Why should you use RDA?
Because I can use any R that goes from the line to any point on the line of action. Is this go from the line, OB, to the force? Yeah, I can use that. Can I use B to C? Yeah, I can use that. Can I use O to A? Yeah, I can use that. Can I use O to C? Yes, I can use it. And I can use anything in between. But in between, I don't have the coordinates of those. So it's useless. All right, let's try another one. Make sure everybody's on the same page. Here we go. Same thing, it says, give me the magnitude of the moment about line AB. This is straight up chapter 4, section 5. What do I need to do? I need to express the force CD in IJK format. Well, coordinates 4, 0, 0. Coordinates of D, 0, 4, 2. Coordinates of A, 0, 4, 0. And coordinates of B, 4, 4, -3. First, let's do chapter 2 to get the IJK of FCD. That's going to be RCD is equal to XD minus XCI plus YD minus YCJ plus ZC minus ZDK. And this pen is about had it. Our CD vector is 0 minus 4. That's minus 4I. 4 minus 0, that's plus 4J. And then 2 minus 0, that's plus 2K. Magnitude, square, 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 add them together, take the square root, 6. So now the force FCD is equal to 540 times the unit vector CD, which is 540 times minus 4I plus 4J plus 2K, divide this by 6. FCD vector comes out minus 360I plus 360J plus 180K. Bingo, I have the force in IJK format. Now remember, what am I trying to do? I'm trying to do moment about AB is equal to unit vector AB dotted with an R cross F. I just found F. I need a unit vector AB. Okay, I'm going to go to my position vector. And I'm going to say R AB is equal to XD minus XAI plus YD minus YAJ plus ZB minus ZAK. RAB vector is 4I plus 0j minus a 3k. Well, shit, this magnitude is easy. That's just 5. Unit vector AB is going to be 0.8I plus 0j minus 0.6k. 4 over 5 is 0.8, 3 over 5 is 0.6, it's a 3, 4, 5. Easy. Yeah? Got it. So I now have this side. Perfect. I need an R. What R should I use? Well, I could use an R that goes from A to D. So RAD is usable. I go from A to C. RAC is usable. I go from B to C. RBC is usable. I go from B to D. RBD is usable. Any of those 4 will work because you're going from the line AB to any point on the line of action of the force. I chose A to D, A to C, B to C, B to D. Any of those will work. Pick one that's easy. A to C is easy. How about A to D?
Yeah.
What's A to D? It's really just 2 in the Z, 2K. So my moment AB is equal to unit vector AB dotted with, I'm going to use RAD crossed with FCD. This is the determinant. 0.8, 0, minus 0.6. RAD is 002 because it's 2K. And then here's the force, minus 360, 360, 180. MAB, therefore, is a magnitude of minus 576. That's it. Nothing hard. It's straight up, easy peasy. Now, it did throw a little twist that says, hey, express this as a vector. What? Yeah. Notice the question. It says, express this moment in vector form. Well, I'm going to say this is MAB is equal to minus 576 times the unit vector AB. That will give me minus 460.8I plus 0J plus 345.6K. There it is expressed in IJK format. Yeah. All I did is I took the magnitude and multiplied times the unit vector of AB. Questions? How many saw the Super Bowl? I only watched the first half.
Yeah.
I was bored. Correct. Not that. I turned it off after the first half. I knew it was going to win. Seattle was winning. No matter what. Huh? No, I didn't watch that. Magnitudes are the same, opposite in direction. If I sum the forces, what's the net? 0. So it doesn't translate anything, doesn't cause any translation. Right? But what it does cause is a rotation. Grab the arrows of the couple. I'm grabbing this arrow and I'm grabbing that arrow. Pull down, pull up. What do I have? A counterclockwise rotation. So what you're telling me is a couple is nothing more than a fancy way of saying moment. Yes. That's all it is. And it's not 10J and minus 10J because you're not expressing these as forces It's a way of representing a moment. So you have to say it is 8 times 10, 80 foot-pounds, and we're saying what? Counterclockwise. Now, the moments don't have to be, the forces don't have to be up, down, they could be like so, they could be like this, whatever. So please note, a couple has no tendency to translate, only to rotate a body, so it's a moment. It's a fancy way of saying moment. The unique feature is that it is a free vector, can go anywhere you want it to go. And the measure of the turning effect of the couple is the moment of the couple, or just simply the moment. And in this case, moment's equal to 8 times 10, or 80 foot-pounds. That's it. That's it. Now, on the test, do not write minus 10J, positive 10J. You tell me these are forces, these aren't a moment. That would be wrong, and I'd mark you off wrong. It's a moment, and the answer is it is 80 foot-pounds counterclockwise. Okay? Now, laws of operation. These are things that are not in the textbook, so you want to be observant to these. These are things that you can do and not affect the outcome. It will not have an external effect on the body. It has the same external effect on the body as if you didn't do any of this. Okay? Number 1. Read number 1 for me. So what was in your text? Did you get one from the girlfriend? Acting along a different line, but parallel if you add a couple. Got it? So, what is that, by the way? What is that statement? That statement is nothing more than the lateral transfer theorem. So I'm the force. I can move myself up or down by the principle of transmissibility. But the lateral transfer theorem says, hey, I can move laterally across if I add a moment or a couple. That's number 1. Number 2, a couple may be rotated or translated in its plane. Number 3, you can move to a parallel plane. And number 4, that distance of 8 in between the 10 can be changed as long as the magnitudes are changed. So I can make that 4 feet as long as the forces are changed to what? 20. Okay? So if you look, the next page, you'll see an example of how I use all of these operations. For whatever reason, I want to take this 10, move it to A, and add a moment or a couple at B and C. That's the objective. So the first thing I did was I went over here and I said, let me put a 10 down, 10 up. At the location A. Notice these two, or in this case, these two, formed a couple. Right? That forms a couple. And I literally moved the 10 over. I moved the 10 over by forming a couple. Next, I took the couple, moved it forward. So I moved it to a parallel plane. You can see I literally moved it forward. Then I'm going to take the couple and I'm going to rotate it in the plane. There it is, rotated. I'm going to translate it down, but notice I get one force at C, but then the other force is not at B. And I want a force at B and C. Right? So now I'm going to change this to a distance so that this guy lands at B. To do that, I said, what's the moment? The moment is 50. Right? Go back here. This is 10. This distance is 5. So the moment is 50 foot-pounds. I'm going to keep the distance to 4 because in between these two, B and C is 4 feet. To do that, I have to change the force to 12 and a half. So I accomplished my goal. What was my goal? put a 10-pound at A and a couple at B and C. And I used every single operation of couples. Moved laterally, added a couple. Moved it forward, rotated in its plane, and then changed the values of forces so I get to the location of B and C. You with me? Those are the operations of the couple. I do not believe they're in your textbook, so you might want to learn these in case you get some sort of question in connection to operations of couples. Now, think back. How many concepts were in this class? 12. How many have we seen? Let's enumerate them. 1, force. 2, moment. 3, parallelogram rule. 4, equilibrium of a particle. 5, Matignon-Young's theorem. Right? 6, principle of transmissibility. 7, lateral transfer theorem. So you have seen 7 of the 12 already. Actually, that's not true. You've seen 8 partially. What's the 8th that you've seen? Is equivalent. Partial.
7.5.
The next thing we're going to do is equivalence to finish it out rather than partially to complete equivalence. That'll be Thursday. See you then.